Hi there, this is the first video lesson for Chapter 15 on acids and bases. There's a few different definitions of acids and bases. The simplest is the Arrhenius definition, and Arrhenius defined an acid as something that produces a hydrogen ion, which is basically an H+. So if you see a chemical that starts with H, odds are pretty good it's an acid. He defined a base as a compound that produces a hydroxide ion, which is an OH minus. So if you see a compound that ends in OH, odds are pretty good it's going to be a base. I will let you read this stuff. It's pretty straightforward. Here's just a definition of a hydrogen ion. And a hydrogen ion is a hydrogen atom with the electron removed. So here's the electron. If you remove that electron, the only thing left is a proton. It has no neutrons, and you removed its only electron, so the only thing left is a proton. So therefore we will use the word hydrogen ion, H+, and proton interchangeably because they all mean the same thing. Monoprotic just means it has one, monoprotic means it has one H, diprotic has two H's, triprotic has three H's. Pretty straightforward. So if we look at these here, we can go through and define these as acid or base. If I look at the first one here, if you want to pause the video, go through and figure out, okay, the first chemical, acid or base, go through these chemicals and figure out which one they are. I'm going to go over the answers right now. So you can pause it, do that, and then check your answers. This first one, KOH, ends in OH, so it's a base. HCl starts with H, so acid. NaOH, again, ending in OH, I know it's a base. First one here is H, so it starts with H, so acid. This one ends in OH, so it's a base. And H2O is kind of tricky. We can rewrite H2O, and we've done this in other units in this class. HOH often is how we rewrite H2O. And if you look at it, it starts with an H, so you think acid. Well, it ends in OH, think base. Water is a special compound for a lot of reasons, and one of them is it is what we say is amphoteric. Amphoteric. And what that means is in some situations it can behave like an acid, in some situations it can behave like a base. Here is an example of, sorry, reading my own notes there for a second. Just in general, and we kind of talked about this, you saw this in the lab, when you add an acid and a base, you get two things. We get water and some sort of salt. I'll let you read that. Parent acid and parent base. This is kind of like reverse of what we have up here. In this example, we have KOH, and KOH here is our base, and I know it's a base because it's and it's OH. HBr is our acid, and I know that because it starts with H. And we're going to make two things. We're going to make water, H2O, and some sort of salt. In this case, the salt is KBr. Now, if I ask for the parent acid or parent base, what I'm asking is, if I give you the salt, like KBr, what acid and what base did we start with? And let me bring up my little writing thing here. The easiest way to do that is if I give you the salt, in this case KBr, and I'm trying to figure out the parent acid and the parent base. I know if it's an acid, the parent acid is an acid, And acids always start with an H. So all I'm going to do is I'm going to replace whatever this salt is starting with an H. So I'm going to get rid of the K and put an H there. Whoa, that just did something weird. So my parent acid in this case, if I take away the K and I put an H in its place, I get HBr. And just like whenever we put two chemicals together that haven't been together before, I got to do the switch trick. If I look up the charge of hydrogen, it's a +1. Br is a -1, so they actually cancel each other out, so I don't have to do any subscripts. But that's one thing you got to always double check is when you put two chemicals together that weren't together before, got to do the switch trick. So that is to figure out the parent acid. Again, here is our salt. If I want to figure out the parent base, or the base that I started with, I know that bases always end in OH, so I'm just going to get rid of whatever it ends with, and in its place, I want to put OH. So the parent base in this case would be KOH. Again, I put things together that weren't together before, got to do the switch trick. If I look up potassium on the periodic table, it's a +1. OH is hydroxide, it's on your polyatomic ion sheet, that's a -1, +1, -1, and they cancel each other out. So, that's parent acid, parent base. There's another example here. It's kind of thinking of it backwards. Up to this point, we've talked about adding acids and bases together, and that's what you did in your lab. You put an acid and a base together. Here it's kind of going reverse. The other definition of acids and bases we're going to use is Bronsted-Lowry. And the Bronsted-Lowry definition says acid is a compound that donates its hydrogen ion. So it's a proton donor. It's an H donor. And by donor, we mean gives it away. If I donate something, that means I'm giving that something away. Base is a proton or a H plus acceptor. So an acid gives away an H plus, a base accepts the H plus. And we can see that in some examples here. Conjugate acid, conjugate base. These are terms that we could say they're conjugate pairs. And you'll see what we do here when we pair these up. I'll do this first one here, HBr. Plus H2O in equilibrium with H3O plus Br minus. So what I do when I pair these up, I start with the first chemical here, HBr, and HBr is turning into Br minus. H2O is turning into H3O plus. You can see that they're kind of similar. The only difference between HBr and Br minus, the things that are paired up, is the difference of an H. Here it has an H, here it doesn't have an H. The only difference between H2O and H3O plus is one H. The charges are going to change, but we're more focused on what actual elements and atoms are there. So that's how I'd pair it up, because HBr turns into Br minus, H2O turns into H3O plus. Now I've got to figure out which one's the acid, which one's the base. Well, if I look at the left, your acid and your base are always going to be reactants on the left side of the arrows. So if I look at HBr here, and I'm going to go back to my definition, an acid is something that gives away an H plus, gives away a proton. Or proton, H plus, hydrogen ion, those are all terms that we use interchangeably. And if you see, HBr has an H over here, and here it doesn't have an H. So it must have given away, it must have donated its H. Because it had an H, then all of a sudden it doesn't, so it gave it away. So that means HBr is our acid. Here, H2O has two H's, and then after the reaction has three H's. So it must have accepted an H in that process. By definition, the thing that accepts the H is the base. Again, your acid and your base are always going to be on the left. And they will be paired up with their conjugates. So the base is paired up with its conjugate opposite. So this would be the conjugate, I'm not going to write the whole word out, acid. Base is paired with the conjugate acid, and acid is paired with the conjugate base. They're always paired with their opposite. So base is paired up with the conjugate acid is paired up with the conjugate base. We will do some more examples of this in class. It's actually kind of hard to do a practice quiz on this stuff, so you'll have a worksheet and we'll do that that last week of this unit. So there's some more examples there. I'm going to pause it and I'll put up the answers for 2 and 3 here. So if you want to pause it, try it, and then unpause it. You'll see the answer momentarily. So here's the answer for number 2. I wrote out the equation, I drew the lines, H2O turns into H3O plus. You kind of pair it up with whatever it looks the most like, and the only difference between one thing and the other in a pair is the difference of an H. H2SO4 is paired up with HSO4 minus. Here we have H2O goes from 2 H's to 3 H's, so it must have accepted an H in that process, so it's the base, so B for base. Here we have 2 H's in H2SO4, and this only has 1 H, so in that process must have donated or given away its H, so that's the acid. And the acid is paired up with the conjugate base, and the base is paired up with the conjugate acid. I'll put the answer for number 3 up here, 1 second. Okay, there's the answer for number 3. I'm going to let's take a look here. Again, I mentioned how water can be amphoteric, and here's an example. If you look at this as first equation, H2O is going from 2 H's to 3 H's, meaning it's accepting an H. So in this case, the H2O would be a base. And in this example, different reaction. We have H2O has 2 H's, and here it's turning into OH minus. It only has 1 H, so it's giving away an H. So by definition, by the Brownstedt-Lowry definition, that is an acid. So in this first example, H2O is acting as a base. In the second example, it's acting as an acid. So you can see it's amphoteric. Depending on the situation, it can act as either an acid or a base. Properties of acid and base, I'll let you look over those. Some naming rules and how to name these. Again, I will let you look over those. For the practice quiz on this, you'll want to know how to do the parent acid and parent base thing and write out these equations. Remember, whenever you put two chemicals together that weren't together to begin with, you need to do the switch trick. That's just a hint for that practice quiz, that first practice quiz. And that's about it for this video. If you have any questions, don't understand something on the practice quiz, be sure and stop in.